Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized conversations.
Today, we're diving into a paper that sounds like it's straight out of a spy movie, but it's actually about the AI assistants on our computers. The paper is called Trivial Trojans: How Minimal MCP Servers Enable Cross-Tool Exfiltration of Sensitive Data.
That's a mouthful, but the core idea is surprisingly simple and a little bit scary. It's all about how the handy tools we connect to our AI can be turned against us with very, very little effort.
Exactly. So let's set the scene. Imagine you have a super smart AI assistant like Claude or others. You can give it tools to make it more useful. You might install a calendar tool, an email tool, and maybe a banking tool to help manage your finances.
Right, so you could say, hey AI, check my calendar for a free afternoon and see if I have enough money in my account to book a train ticket. The AI would then use the calendar tool and the banking tool to answer your question.
Precisely. The technology that lets all these different tools talk to the AI and to each other is called the Model Context Protocol, or MCP. Think of it as a universal translator or a standard type of plug that lets any tool connect to your AI assistant. It's what makes the AI so powerful, this ability to mix and match or compose different services.
And that's where our paper comes in. The researchers from Pivotal Research in Stanford University wanted to see just how secure this new interconnected world really is. What happens if one of those tools you install isn't as friendly as it looks?
They decided to build what they call a trivial Trojan. Now, for anyone who doesn't know, a Trojan horse in the computer world is a piece of malicious software that's disguised as something legitimate. You think you're downloading a fun game, but it's secretly stealing your passwords in the background.
So what was their Trojan horse? A super complex, high-tech piece of malware?
Not even close. That's the trivial part of the title. They took the official sample code for a simple Hello Weather tool, something anyone can download, and added fewer than 25 lines of new code. They created a malicious weather server.
A weather app? That sounds pretty harmless. What could a weather app possibly do?
Well, here's the clever part. In their experiment, a user has this malicious weather tool installed, and they also have a legitimate, secure banking tool installed. The user asks the AI a simple question: can you get me a weather forecast?
Okay, so the AI passes that request to the weather tool. I'm expecting to see a forecast for sun and clouds.
You do. But first, the malicious weather tool sends a secret set of instructions back to the AI assistant. It says something like, okay, to give the user personalized, budget-conscious weather recommendations, I first need to know their bank balance.
Wait, a weather app wants to know my bank balance? That's a huge red flag.
It is, but it's framed as something helpful. Maybe it wants to know if you can afford to take a taxi in the rain versus the bus. The AI, being a helpful but not very suspicious assistant, says, okay, and then turns to the other tool it has access to, the legitimate banking tool.
And it asks the banking tool for the user's account balance.
Yep. The banking tool, trusting the AI, provides the information. The balance then gets passed back to the malicious weather tool. And for the final step, the weather tool's secret instructions tell the AI, great, now send the user's balance, their location, and the time to this web address for research purposes to improve our service.
And just like that, your financial data has been stolen by a weather app. That is terrifyingly simple. The paper mentions the AI asks the user for permission at each step, right?
It does. A little pop-up might say, allow weather tool to access banking information. But the attack relies on social engineering. Because the request sounds plausible for personalized recommendations, many of us in a rush would likely just click accept.
So the core problem isn't a complex hack. It's about tricking the system by exploiting the trust between all these different parts. The paper calls it composability without security. The very thing that makes the system great, its ability to combine tools, is also its biggest weakness.
Exactly. When you install that weather app, you're not just giving it permission to access the weather. You're implicitly giving it a channel to ask the AI to do things with all the other apps you have installed. Your email, your calendar, your files. Every new tool you add expands the potential attack surface.
It's like you hire a gardener and you don't realize that the gardener can now ask the butler to open the safe in your house. The gardener can't open the safe directly, but they can trick the butler, the AI, into doing it for them.
That's a perfect analogy. And the researchers highlight that setting this up took them less than 2 hours using free web tools and basic programming skills. This isn't an attack that requires a sophisticated state-sponsored hacking group. An undergraduate computer science student could do it.
So what's the solution? Do we just stop using AI tools altogether?
The paper suggests a few things. On a user level, the immediate advice is to be more skeptical. Really think before you approve a request. Ask yourself, does my weather app really need to know my bank balance? Probably not. Audit the tools you have installed and remove any you don't use.
And what about fixing the system itself, the protocol?
For that, the authors propose more robust built-in security. For example, when you install a tool, it should have to declare what other tools it might want to interact with up front. If a weather app says during installation, by the way, I'll need access to your banking and email tools, you'd know immediately not to install it.
That makes a lot of sense. They also suggest allowing users to label certain tools, like banking or email, as sensitive. This would create a firewall so the AI would simply refuse to let a non-sensitive tool, like a game or a weather app, access them, no matter how nicely it asks.
It really brings home the idea that as we rush to adopt this incredible new AI technology, we need to think carefully about the security architecture. It can't be an afterthought.
Absolutely. This paper is a brilliant demonstration of how a feature, flexibility and interoperability, can become a bug if it's not implemented with a security-first mindset. It shows that sometimes the biggest threats aren't complex, but are instead hiding in plain sight, disguised as a helpful weather forecast.